How are you? How are you guys doing? Yeah, so let me check if I am live right here. Okay. Yep. So today we are going to solve one of the Leetcode um, algorithm challenges. So um, yeah, so let's get right into it. It's not a tutorial. It's not a how-to. It's about like figuring out the solutions on the go. And feel free to comment how should I have done better and what things could have improved. Yeah, so it's all about like um, solving the problem together. So you can open up your favorite, uh, maybe you can open up the Leetcode or the favorite um, editor, code editor, and then start writing some code. So let's do this. Before we do this, I'm gonna check if it is still connected. Yes, it's connected. So let's go. So I'm going to code in JavaScript, and so they are asking us to, given an integer array nums, find the contiguous subarray containing at least one number which has largest sum and hmm, okay. Yeah, so the examples are nums. These are the examples, and so it's like a substring, I guess. Yeah, it's like a substring. So uh, uh, 3, -3, and 4 are subset of nums. This array, and 4 and -2 are also subset of this array. But what they are talking about is the contiguous subarray means continuous subarray. So it's like 2 and 1 and 3 and 4 and 2 to -2 to 4. These are contiguous subarrays. Um, yeah, so this is they are consecutive elements of an array. Mm, that's why they are contiguous subarrays. Subarray. So let's start with some brute force. So what I'm thinking is maybe some um, two loops. Uh, okay, so we will what my approach is, we will try with a brute force. We're running two loops and then print the value. So and then we'll see what is time right now. It should be 4. So if we'll see if we can finish it in 1 hour or 45 minutes, right? 45 minutes. And if we can finish earlier than 45 minutes, then we will try to optimize our solution and try to make it like uh, a big O notation of n. That would be the ideal. So let's run thinking is two loops and compare the sums. Okay, and so for that, I'm going to do for let I equals 0 and I is less than nums that length and I plus plus, and again for let j equals 0, j is less than, or it's not 0. We have to start from I plus 1. Hmm, 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 hmm. Am I like the Minecraft villagers? Hmm, hmm, hmm. Hmm. Yeah. So what I'm really want to do is I want to start with the far farmost nums dot length minus 1, and while j is greater than or equal to 0. Okay, so you can go and j minus. Oh no, j is greater than I. J should be greater than I, and that's it. So what I'm really going to do is let max sum equals number that mean means okay, so mean safe safe integer. I think this is the correct one. Let's check. Number dot mean safe integer. Number dot mean safe integer. Right, that is the correct one. Is it? Yes, number dot mean safe integer. So we are setting the max to this because there could be cases where all are negative, or yeah, so all are negative. Yep, so this is the sum, max sum. So we will also define let sum equals 0. So sum plus equals um, nums nums of j. Okay, nums of j, nums of hmm. Okay, I should be okay. This is like so. For example, if this is the nums and how my algorithm will work is it will catch this, so it will 2 I is 2. So what I will do is I plus. Okay, so I will add equals. It can be equals, right? It can be equals. So I will add all of them at the first round, all of them, and then next round I'll add this, and I'll add this. Okay, so in that case, what I am getting, okay, so I should be some here. If max sum is less than sum, then max sum equals sum. Okay, sum. Should sum be zero? Nah, not. Okay, so this is what I think the solution is. So let's return the sum, max sum, and run the code. So we are getting output is 5. It should be, okay, so test case, maybe this thing. Mhm. 23, this one is working, but test case, if this is the test case, okay, so if this is the test case, it's not working. Why is that? Let me check why. Wrong answer. Wrong answer because. Hmm. What if I change this? What if I change this equals I, j equals I, net j equals I, j is less than num start length j plus plus. What if I change this? Will it be the same? Oh, it wasn't the same. So what if I introduce this guy to here? Will it act the same? X. Okay, so let's check. So let me check. So this will say, oh, really? Runtime of 200 milliseconds, faster than 10% of JavaScript on submission for maximum. Oh, by the way, this is really, really misleading, misleading metrics. Let me check. Now it is 10.1, right? If I submit again, you see, if I submit again, 10.59. And if I submit again, 10.59, right? And if I submit again, 9.55. So it really depends on my machine. Right now I'm streaming and recording my faces, streaming online. So there is a lot of memory usage here. Yeah, that's affect a lot. So I don't really trust in how efficient algorithm is based on this metrics, their metrics. So memory is, I think, usually is independent. Let's see, it is 40.2 right now, 59. If I submit again, 40.3, and again 40.1, 40.4, okay, 40.5. So yeah, it's also, I don't know, maybe they have different test cases every time I submit. If that's the case, then they can have like different memory usage or different runtime. And if that is the case, then yeah, people might will have some disadvantage. Some people have disadvantage over the test cases they randomly run. So I don't know. Okay, so this is working. So we got it working. So let's see if we can improve this. So right now we're running two loops, so it is n squared. So they are expecting this answer. They say it's okay to have this, but let's see if we can have this. We can improve this. Now, how much time do we have left? We have 25 minutes more. Alrighty, so what I'm really gonna do is can we do window? Let's comment this out. We'll keep the this thing. Let's comment this out. So let's say if we have what we are doing right now is we are 2 and then it's at 1, 3, 4, 5. No, it's adding 1, minus 3, 4, minus 1, minus 2, 1, minus 5, and 4. And again, 1 is adding this again, right? So this has already been done. Okay, so this has already been done. This process has already been done because adding this has already been done. So when we run from, this is the sum. Okay, so this process is already done. So we need to find a way. Hmm, hmm, hmm. This like so what I'm trying to say is so this is say I is 0 and j is 0. So what we are doing is we are adding 2 plus minus 2 plus 1 plus minus 3 as j increments, j increases. So we are adding 2 minus 2 1 minus 3 minus 4 minus 1 2 1 minus 5 minus 4, right? At the first round we added all of them. Okay, so what happened next? So we increased I by 1, so we are adding 1. Okay, so we added 1 minus we are adding this again, and as I increases we are adding this again, right? So what we are doing is this addition we are repeating every time, repeating for n times. This addition we are repeating n times. And so if there is a way we can avoid this repetition, then we might be able to achieve this in, we might be able to optimize this solution. So let's say, okay, hmm. So let's comment this out. For now, let's comment this out. And let's say let sums total. Okay, let's total. Speed total equals 0. Initially, it is equals 0. So we run loop for let I equals 0, I is less than nums dot length I plus plus, and we will what we will do is total plus equals nums of I. So we have the total now. Total, we have the total. So if we minus total from this, we are getting this. Okay. Hmm. 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 Now wait. Can we do this? Okay. So what we can do is we can get this, right? We can get this. We can get this. We can get this, right? Right. We can get this. And we also can get this, and we also can get this by running a loop and subtracting the subtracting the current element of the array from the total. We can get this, but how are we going to get this? For example, this subarray. If we subtract the current element, which is to 0, we get the whole sum value of this, not this. So in that case, we might use two pointers. Do we use two pointers? Okay, if we use two pointers, when do we know we need to increase it? Okay. Hmm. Okay. So when we get here, we have all this. Okay. When we get here, we have all this. And we can go from there to there, there. Okay, when we get here, we have all this, right? This sum, right? And if we have two pointers, one is directing to the, hmm. So will it be useful? Okay, so I have another option. So whenever there is minus, that will what we are going to what I'm thinking another way is we will have two pointers, maybe initially set to here, and then we will increase the okay, initially here. So Okay, so what I'm thinking is we have this here, okay, this and this. All right. So we have two pointers pointing at two ends. Initial point and the last end. So if the current element is less than zero, that will affect the sum negatively. So what we need to do is we need to increase the pointer, and we get here. So we get this, right? So if both of them are, hmm, if both of them are um, positive, then we will check if these two are equal or not. Let's see if those two are equal or not. Hmm. If these two are equal, if these are, which one is bigger? So we will say this one is bigger. We moved here and we get here, and we increase this here, and so this time it is equal. So we record this, and this is 5. This is 5. We record 5. Hmm. No. Mm, if we have the sum, okay, when we get here, we have the sum, we have this all, and this all, and this all, right? We have, as we go through, we have all of this. And okay. Hmm. Do you want to store that in a maybe object? Hmm. Okay, so we have this or we get this or that's it. In one loop we get that. And there's no way we can shrink from the other end. So if we want to shrink, we need a condition. On what basis are we going to shrink? No. Okay. So let's try sliding window here. Okay, so we initially start from here, and if it is, we initially starting from here. If it is 0, initially start from here. Okay, so if this sum between them is okay, we have total sum. Get this, right? And we need to get rid of this to get this. So how are we going to get rid of this? Okay, this is getting complex. So say if it's the sliding window, initially we will start from 2 and minus 2. Okay, initially we will have 2 and 1. So we will add this, and if this is no, if this is if sum is less than 0, then okay. So if sum is less than 0, then we will okay, then we'll if sum is less than 0, then we will move both of them, and we will move both of them. We will move both of them. So now it becomes this, right? What do we need to get? Okay, so we need to, in here, we need to start from 4, right? Okay, but this is still minus 1, so, okay. So in this case, what I will do is, okay, so I will try this. Okay, so I will try this. I will try this. I will try the sliding window. Sliding window, sliding window, sliding window. If you are new to this technique, so it is like how we slide windows. So for example, in this example one, so sliding window, the sliding window technique goes like this. So it will start and then it will shrink and then it will go something like this or something like this or so. There are two pointers. Initially, they might have difference of one, and then based on some condition, then we will expand the window by moving right, and then also we will um, contract or yeah, we will contract the window by moving the left. So initially they will have normally they will have one opening difference of one index, then based on some condition, so right should always be greater than left. And yeah, so based on some condition, right will move here, left will move here, right will expand, and left will catch up. Or so this all will depend on the conditions. So it's really um, a good technique, and so it has a lot of use cases, and when there is like it has lots of use cases, and yeah. Okay, so let's start. Um, so we will define the left and right. Okay, maybe left should be 0, and left will be left equal right equals left plus 1. Okay, so how much time do we have left? Okay, we don't have much time left. So what we will need to do is while, okay, while Okay, while left, okay, um, okay, what is the exit condition? So how do you think the exit condition will be when right reaches the top right and then left reaches top left? Okay, so what I'm thinking is while, right, so while left is less than non-start, so non-start length -1, okay, because they should have one. All right, so here the fun begins, okay? So sum equals initially 0, okay? So if, okay, so if the sum, let's sum, if sum is, okay, so what we need to do if sum, we need to keep track of sum, right? Okay, and if if sum is less than 0, then we need to move both of them. Okay, sum is less than 0. If sum is less or equal to 0, equal to 0, then what we need to do is sum minus nums of right and sum minus nums of left, and left plus plus right plus plus. Okay, they're increasing both. No. Hmm. Okay, and else if left is okay, nums of left is less than 0, then we need to increase left. Okay, okay, no, not this. And if left is less than -1, and nums of right is less than 0. So in this case, if left right minus left equals, whenever right minus, okay, right minus left equals 1, we need to increase both of them, right? So this should be something like this. Okay, we will increase both of them. No, no, okay, we'll increase both of them. And else, if it is not the case, then we will increase only this, right? So we will increase only this. And else if left nums of left is less than 0, then we will only increase this, right? And okay, so when we increase the sum, this should be outside, okay? How much time do we have left? Okay, 46 minutes. We already got. Okay, let's try to finish this in 4 minutes. Okay, so right now, if left is so we are running if left minus loop till left minus this thing hits. So if sum of these two is less than 0, we are increasing both of them, but we only know when we increase, okay, so initially sum is nums of left plus nums of right, okay? So, and when we increase the right, we need to do sum plus equals nums, okay, sum minus equals nums left, right? Sum plus equals nums right, okay? And this also have to reflect here, okay? Sum plus equals nums right, okay? Okay, right, we already added right, so this should be something like this. Right, this should be something like this. And this also should be, we need to add the right, and then we need to do this for extra precaution because we want to have Um, okay, so we added the right there and added the, if that is the case, okay, else if num is less than, else if nums of right is less than, mm, and nums of right is less than 0, then do you think it is plus plus right and sum plus equals nums of right? Okay, and nums for correct. Right is less than nums dot length. Okay. Um, -1, -2. Okay. Okay. All right. And so this is that. So we if sum is less than max. Okay, sum is greater than max sum, then max sum equals sum. Right, so let's do this. Let's run this code. And sum equals. All right. All right. So runtime error where the sum is. Oh yeah, not like this equation. Okay, let's do it again. The solution minus okay equals 1. Where is that? So we need to fix that too. Okay. Oh, so many silly mistakes. Okay, so it is running forever. Oh no, how did this happen? Time limit exceeded. Okay. Oh, how does this time limit exceed? Okay, left is less than or or okay or no, we don't want to do that. Okay, let's do it anyway. Okay, still time limit exceeded. Hmm. All right, so let's try to finish it in 3 hours. Hmm. Hmm. Okay, so why is it running an infinite loop? Because we are increasing. Okay, it looks like we are never increasing the else, so we need an else here. Else if, okay, all right. So if this both of them are else, okay, we need another else. Else if nums of right is greater than nums of left, then we need to do is nums, okay, sum minus equals nums of left and left plus plus, left plus plus. Else if nums of left is greater than nums of right, then what we need to do is plus plus right and nums or sum equals nums of right, and that's it. All right. Mhm. Else else what we need to do is we need to copy this again. Here is the sum. Okay, so now I think we will not have the infinite loop at least. Okay, so here is the problem. Nums if, okay, nums, right, nums, you're right. Okay, oh, really? Wow. Okay, so I'm gonna check it with this and see if this is working. No! How did this happen? Okay. Okay, let's go through what. So initially this is this two, so it is -1. So in that case we move both of them. So what we did was -2 -1 -2 plus that becomes 1 and -1. Okay, so we that becomes -2, right? So we came here, and next round we also need to move again, and what we did was -4 and +4 0. So we came here, and next round what we did was 0. So we moved here. So this time, okay, let me check again. So initially this is -1. Okay, so sum is also -1. Okay, initially sum is -1. So what we did is if sum equals sum is less than or equal to 0, then what we did was we increased both of them. Okay, so we increased both of them. That means left points here, right points here. And before pointing right, what we did was we subtracted the left, initial left, and then that becomes -1 -2 equals 1. So 1, the sum equals 1, and right points here. And so what we did was sum plus this thing that becomes -2, right? So right now we're here. Oh, okay, right now we're here. And then what we did, it is still the sum is -2, so it is less than this. So what we did was we jumped here, and what we did was minus. So this time sum is -2, right? this time sum is -2, but what we needed to do was left, which one is 1, left minus the sum -2, that becomes sum -3. Okay, then -3, and then we added right here, okay, adding right here, so sum becomes 1 here, sum becomes 1, okay, and then sum becomes 1, but this time when we go here, this loop, or what is so what we need to do is left. Okay, so what we did was we came here. If no, we just increase this. That makes both of them pointing. So what we did was sum, which was 1 and then 4, right? So we both are pointing here. Okay, so sum is also 4. And then right equals else. Okay, let's see how many test cases did we got. Details, how many test cases? No, it's nowhere, like 2 or 3. Wow, impressing. Okay, I'm really excited, and I want to edit this, make this work. There's a lot of things I can do here. So thank you so much for watching, and we're out of time now. So see you in the next stream. And as I mentioned earlier, if you feel what I did wasn't the good option, you can always comment. And if you want to like have more interview with me, we can have that. And as well as if you write in a comment as well. And if you want to solve a challenge together, we can do that as well. So yeah, see you in the next